Today's video is solving quadratic functions by factoring, part 2. So how we solve these functions isn't going to change. As you can see, we still have the same 4 steps that we had yesterday or in the last video. And we're going to use those same steps. The part 2 is really just us applying this to maybe some more complicated equations. So we're going to make it just a step or 2 harder for us. So as a reminder, when we solve quadratic functions, solving really means to find the x-intercepts. We're trying to find the x-intercepts. And if you recall from the last video, what else can we refer to x-intercepts as? That's right, we can refer to them as zeros. So x-intercepts are zeros, and the reason why they're zeros is because they make the function equal to 0, and they are on the x-axis, where y is 0. They are literally the x-intercepts of the graph. So the zeros and the x-intercepts are the same thing. So let's go ahead and use our steps to help us solve some equations. So in example 1, part A, we're going to jump right into that equation. Step 1 says to make sure that the equation is equal to 0 and in standard form, of course. So n squared minus 12 equals negative 3n plus 6. This is not in standard form, and it's also not equal to 0. So we need to try to make this thing equal to 0. Well, the n squared is on the left side of the equal sign. So I'm going to move negative 3n and 6 to the other side. Right now they're on the right side. I'm going to move them to the other side. So how do I move negative 3n to the other side of this equation? I add it. And then how do I move positive 6 to the other side? I subtract it. Okay, let's simplify. What's 6 minus 6? 0. What's negative 3n plus 3n? 0. So now what do we have left on the right-hand side of this equation? 0. On the left side, I have n squared minus 12n minus 6 plus 3n. I need to combine like terms if I can. So n squared doesn't have a like term. The 3n doesn't have a like term. But then negative 12 and negative 6 can be combined. So negative 12 minus 6 is negative 18. So now we have n squared plus 3n minus 18 equals 0. Now our equation is equal to 0, which is what we want. And the left side's in standard form. So the standard form of a quadratic equation, just as a reminder, is y equals ax squared plus bx plus c. So you have your x squared terms first, followed by your x, followed by your constant c. And right now we have that. And then what has replaced y in this equation? Y is simply 0. All right. So we're ready for step 2. Step 2 says to factor the degree 2 polynomial. So we need to factor this left-hand side. So I know that n times n is n squared. What factors of 18 add or subtract to give us 3? Well, let's make a factor tree for 18 off to the side here real quick. Let's see, 18, 1 and 18, 2 and 9, 3 and 6, 4 and 8. Which of those add or subtract to give us 3? The 3 and the 6. So let's use 3 and 6. And then I need a negative when I multiply and a positive when I add. So that tells me that the larger number needs to be positive, the smaller number needs to be negative. Is negative 3 times positive 6 negative 18? And will negative 3n and positive 6n get us positive 3n in the middle? Yes. So we know that we factored this correctly. Step 3, set each factor equal to 0 and solve for x. So down here, we're going to set n minus 3 equal to 0. That's one of our factors. And then the other factor is n plus 6. So n plus 6 equals 0. Remember the zero product property? If something times something equals 0, then either this needs to equal 0 or this needs to equal 0. So let's add 3 to both sides, solving for n equals 3. Subtract 6, so n equals negative 6. And then step 4 is to simply write your final answer, and of course, check it. So we have n is equal to 3 and negative 6 as our final answers. So let's check just to make sure that we're right. So we're checking this in n squared minus 12 equals negative 3n plus 6. I'm going to plug in 3. So we have 3 squared minus 12 is equal to negative 3 times 3 plus 6. So 9 minus 12 is equal to negative 9 plus 6. 9 minus 12 is negative 3, and negative 9 plus 6 is negative 3. Well, that does work. Now we need to plug in negative 6. So I'm just going to erase this so I can use that spot again. So negative 6 squared minus 12 equals negative 3 times negative 6. Plus 6. So this would be 36 minus 12 is equal to 18 plus 6. 36 minus 12 is 24. 18 plus 6 is also 24. So yes, both answers do give us a true statement. So we know that our 2 solutions are correct. Okay, so I'm going to get you started in part B and then ask you to finish it on your own. For part B, we need to make this thing equal to 0. So again, we're going to move 10 to the other side, and we're going to move negative 10x to the other side. So this equals 10 minus 10 is 0. Negative 10x plus 10x is 0. So we're left with 0 on the right side. This side becomes 2x squared plus 14x plus 20. Now, remember, the next step is to factor this thing. But when we factor, one of the things we have to look for are the GCF. Does 2, 14, and 20 all have a GCF? Yes. 2 goes into all 3 of those terms. So we're going to factor out that 2. And we're left with 2 times x squared plus 7x plus 10 equals 0. Well, check it out. This 2 out in front, does this 2 have a variable attached to it? No, it does not. So the 2 isn't going to help us solve for x. So I'm going to show you a little trick. This says 2 times this, right? What's the opposite of multiplication? Division. So what if I divide both sides by 2? Well, what's 2 divided by 2? 1. So if I have 1 times x squared plus 7x plus 10 is equal to, what's 0 divided by 2? 0. Now, if I distribute this 1 times x squared, 1 times 7x, and 1 times 10, is that going to change anything? No, it's not. So I'm left with x squared plus 7x plus 10. We don't need that 1 out in front anymore. So what we did was we basically just divided this entire equation by 2 and simplified it to make factoring it a lot easier for us. So now we're going to go ahead and factor. X times x is x squared. And then go ahead and pause the video and hit play when you're ready to check your answer. So when you finished factoring this, you should have found that it's x plus 5 times x plus 2. You set x plus 5 equal to 0, x plus 2 equal to 0, and solve for x in each one. So x equals negative 5, and x equals, subtract 2 from both sides, so x will equal negative 2. So your answer is x equals negative 5 and negative 2. And you should go through and check it on your own. Just make sure that both of these values make the original equation true. Move on. So before you solve this problem, we actually need to change it because I believe there's a typo in it. Instead of 15x, this actually needs to be 9x. So when we solve for 0 and we put this into standard form, we need to add 57 to both sides. We need to subtract 15 to both sides and subtract 9x. So now, negative 57 plus 57 is 0. 15 minus 15 is 0. 9x minus 9x is 0. So our right side is now 0, which is what we want. Then on the left side, we're going to go ahead and simplify this and combine our like terms. 3x squared doesn't have a like term. Negative 18x minus 9x can be combined to negative 27x. And then 57 minus 15 is 42. Okay, so what I notice is that 3x squared, negative 27x, and 42 all have a common factor of 3. So let's factor that out real quick. So we're left with x squared, negative 9x, and 14. So now we're going to divide both sides by this 3, so it'll cancel. And we're going to have x squared minus 9x plus 14 is equal to 0. Then you should have factored this left-hand side. And we're going to have x minus 2 times x minus 7. Then you're going to set each of those factors equal to 0. And add 2 to both sides. So x equals 2, add 7 to both sides. And so we found that either x equals 2 or x equals 7 will make this equation equal to 0. So our final answer is x equals 2 and 7.